All right, this is lesson 25 in Algebra 2 from IM topic 2. We're focusing on rational functions. 25.1 is a notice and wonder. So it's whatever you notice, whatever you wonder. You're not going to be right or wrong. A couple things I'm going to point out to you. If you look at these shapes, total numbers of triangles added since the first, it's going to be a little different than what you might think. Because if you look from here to here, it doesn't look like there were 3 triangles added. So what I had to do is if you look and you fill in this right here was your first triangle. So then they added 1, 2, 3. Originally, I thought they would overlap, but that didn't work, so that's how they're doing it. Then you can repeat the process, but it does get a little harder to be more accurate. See what I mean? Okay, so this is our first one still. And then we had our ones like this. I have to look at the top picture to make sure I'm doing this right. And this is really just to help you see how they're changing. So this was the 1, 2, 3. They said you added 3 times 4 because you're adding here and here and here and here and here. So it's 3 times 4, which is 12. If I actually shade them in, I'm trying to keep them different so you can see the difference. There we go, so that's what's happening. The iteration just means how many steps you've done. So then it's going through the patterns. And then this is the more generic answer for that. So you have that to look at. You don't have to do it how I did it, but that might help you see where the triangles are coming from. And this is something we're gonna need for the next part. Okay, first things first, if you do not have a calculator with you, you are going to want it for the rest of this topic or lesson because you're going to be using an equation. So I actually don't know how to pronounce the type of snowflake it is. I've heard it pronounced different ways. It's the number of triangles added on. That's what we were just doing. A is 3, R is 4. It goes through the generic one that we talked about that was in the last row where it's to the R or R to the n minus 1. What would happen? This extra parenthesis from the hint, so don't let that throw you off. If you multiply both sides by this 1 minus r, this kind of plays in similarly to what we were doing when we were talking about identities, in that when you have it, all of your middle terms are going to cancel. So if you did a 2 by 4 box with that, you would just end up with x to the 4th minus 1. If you multiply both sides by 1 minus r, it's going to be something similar to this where it's going to cancel. The new equation is called the geometric sum formula, and what it's going to simplify to is that s equals a 1 minus r to the n over 1 minus r. Okay. This a is your initial amount or your starting amount. The r is your rate. And then this, I don't know how to word it. I just say the number of whatever because it represents different things. It can be years, it could be days, but it's not always just time either. It could also be like when you take an antibiotic and you take it twice a day, it could represent number of doses, which is not going to be a time because it's 2, 3, however many times a day for multiple days. So that's not a time period. So that's why I use the whatever. Use this new formula to calculate how many triangles after the original are in the first 5, 10, and 15 iterations. So our equation, we started with 3 because A is 3 and our R is 4. So we're going to have for 5, 3, oh my goodness, sorry. Cat screamed for some reason. And it tells us we're adding, but if we follow this, 1 minus 4 to the 5th power over 1 minus 4. Because this 5 is our R. And then we're going to do it with our 10. Oh my, no. And our 15 as well. This is where the calculator really is going to come into play. As long as you make sure to put the number in the right spot, unlike me earlier. All right, so if you have a nice calculator, you can do this all in one go. Unfortunately, I didn't think about bringing my calculator home with me. There's 2 different ways you can do it. Well, multiple different ways. You can do what is in the parentheses first on its own. You can just do the top first and then divide. You can do basically whatever. And then multiply by 3. You could also put that 3 in the numerator and do it that way. So I get 1023. And I'm gonna double check that just because I was talking while I did it. So I have to do it step by step. 1 minus 4 to the 5th gives me negative 1023. And then I divide by 1 minus 4, also known as negative 3, which gives me 341. And I times by 3 again, which brings me back to 1023. Okay, I'm going to repeat that process with 10 and 15. I would pause it right here so you can get used to putting this into the calculator, whatever type of calculator you're using. Okay, so you got some big numbers. You have 1,048,575, and you have 1,073,741,823. I know that looks huge, but if you go back to our picture that we did and you look, it was jumping quite a bit. It jumped from 3 to 15 to 63. So it's jumping because look at all these little tiny triangles you're adding, and then you're going to add more tiny triangles off of those. And so it does make sense after you've done it, 10 times, 15 times. So we're going to use that equation we just wrote for Han's antibiotics. And this actually is perfect timing. My daughter just finished her antibiotics from a double ear infection. My son had an ear infection that he had antibiotics for a couple weeks ago. And they're very commonly used, right? So he's going to take a 150 milligram dose every 12 hours for 15 days. So be careful with this. He's curious about the antibiotic and learns at the end of 12 hours, only 5% of the dose remains. Really quick, I want to talk about your rates. So if you have like an antibiotic or something left, 5% is 0.05. This would be like 5% remaining. This is if you are decaying, you're getting smaller. If you are increasing, such as interest, which is the most common increase you're going to see, 5% interest or increase is actually going to be 1.05 as a decimal, because this 1 represents 100%, which gets you back up to the original amount plus 5% more. This is the shortcut. What you're really doing is you're taking 100% plus 5% and adding it together. This will get you there faster. So keep that in mind, and then be very, very careful. 50% is your 0.5, but we are looking at 5%. Also, if you haven't watched my other videos, you haven't learned I don't write my 0 in front, but you definitely can, and your calculator will more than likely put a 0 in front for you. All right, brief detour done. Let's go back to our problem. So he has 150 milligrams. That's our starting amount. The first dose, that's it. It's just 150, right? He took it. He has 150 milligrams in his body. That's it. Done. The second dose, he has 150. We have our 1 minus, and you're going to have that 1 minus no matter what. That does not change. The 5%. So 0.05. And then the other thing you're missing is the number of doses that's going to go up there. So technically right here, you could have done the 1 minus 0.05 to the first. We used our common sense and we knew there's no leftover antibiotics. That is it. So we're going to go from here and we're going to evaluate it. When you evaluate it, you're going to get 157.5. I had some students the other day when we were doing this in class get confused because it was more. There's 5% left of the dose at the end of 12 hours. So when he's taking his second dose, or when you're taking your second dose if you've done antibiotics, you have the 150 that has decreased until there's only like 7.5 left. That's 5%. Plus the 150 of the new one you're taking. So there's a tiny bit left of your first dose and then the full amount of that 150. So then your third, hypothetically, might be even more. Let's look. We have 150, the exact same situation, exact same equation. I'm gonna put a 3 up there instead, and you should get 157.875. So you have a teeny tiny bit left from that first, 5% left from the second, and then the 150 again. So just a little bit more. When will the total amount of the antibiotic be highest over the course of the 15-day treatment? What do you think? I'm gonna say probably the last day and the last dose, because you're gonna have teeny bits from prior ones that are still kind of there. So 15 days, 2 doses a day means that the last dose is going to be the 30th dose. Again, that's because you're taking it twice a day. Every 12 hours means twice a day for 15 days. So he'll have done 30 doses. So we still set up our equation. And let's see what we get. So, put this in my calculator real fast. I don't think I did it right. Oh, yes I did. Okay. You get 157.89, and I'm gonna round to 5. So a little bit more than the third dose. Again, that's because you're gonna have little tiny amounts remaining from prior doses. And you could also, if you wanted to set up a table for your 30, you could do it that way to look and double check too. This is my gut feeling that it's the last dose. If you think one of them is gonna be greater than that, you definitely should set up the table. And if you were to set up a table, you would have dose from 1 to 30, and then your amount. And you just plug in the equation. You know this is 150, this is 157.5, this is 157.875, and this is 157.895. And then you could fill in the missing 26 numbers, 27 numbers, however many numbers. So let's look at some practice problems then. Question 1 is so similar to what we just did in 25.3 that if you want more practice and you didn't do the table, or you did the table and want more practice, you should try this on your own and pause it right here, because I am going to talk through it and then do it. So 120 milligrams is your A, 12 hours for 8 days. So twice a day for 8 days. After 12 hours, 6% of the drug is left in the body. How much of the drug is in the body after the last dose? So this is like that second part of 25.3, question 2 we did. 120, 1 minus 0.06, twice a day for 8 days means there's 16 doses. And then we have our divisor. And let's see what we get. Gotta type this out here. make sure I do 16. That I don't think is very common. My daughter's was 7 days, and I've seen a couple that are longer than that, but I've never seen an 8 before. Sorry, it takes me a minute because I gotta do it by hand since I didn't bring a bigger calculator. 127.6, and I'm gonna say 66 because it's 65957. If you give me a second, I am going to double check it just really fast because I want to make sure I'm doing this right. And it's good to double check your work from my previous mistakes that happen all the time. And I don't have people to call me on it right now. Yes, okay, 127.66. That's how many milligrams are in his body after the last dose. So the formula for the sum S of the first n terms in a geometric sequence. This is going back to topic 1 in IM. Geometric means you're multiplying, and it's kind of like dividing too. They tell you your A and your R value, so the first 4 terms of the sequence. Well, your first term is going to be 10 because that's your initial value. Then you can plug it in. I'm trying to think how I want to do it. Okay, let me show you this way. I'm just going to set up the equation for every single time. R is 0.25. This is why we write in pencil too, by the way. Math is not something you probably want to do in pen. So there's your first one. Your second looks very similar with a 2. Then you'll do it with your third. And your fourth. I feel like my writing is getting bigger and bigger each time. Okay, we know this is going to be 10. Why don't you pause right here and take some time to evaluate that while I do it too. Before we do the sum of the first 17, sorry, I was just making sure that I was setting it up right. Okay, your 17th term will be like that. Okay, so when we do this, we get 10, 12.5, 13.125, and then it starts getting bigger. You can round. If this were topic 1, you would have started with 10 and you would have been multiplying by that 25% increase. If you round when you're using sequences and you're multiplying by that 25% increase, your answers are going to start to change and shift slightly. Using this formula, it's going to be more exact. This is kind of like the explicit formula we did instead of recursive, where it is more exact. And it's easier, right? You don't have to start here and multiply over and over again. You can just plug in the numbers to make that work. Okay, and we got one more practice problem. It's about caffeine and how it stays in your system. Similar to the medicine, it's going to drop, but then if you drink more, it's gonna start up again. I don't know about y'all, but I do enjoy caffeine, so this is always really interesting to me. Not interesting enough to quit drinking caffeine. So she drinks a cup of tea every morning at 8 a.m. for 14 days. There's 40 milligrams of caffeine in each cup of tea she drinks. 24 hours after she drinks the tea, only 6% remains. So she starts at 8 a.m., there's 40 milligrams. The next 8 a.m., there's only 6% of that left, and then she's going to drink it again. So first, second, and third. It's 14 days, so you're only going to have 14 doses. It's not twice a day or anything like that. The first, we know the drill. That's literally just going to be the 40 milligrams. The second, she's going to have the 40, 1 minus 0.06. So similar to the problem we just did, just a different starting number. Well, I guess it was the first problem we did. 0.06, second day. And then we'll go ahead and set up the third while we wait to evaluate. And then the highest during the 14 days, again, I would probably say the last day, but this is also a good opportunity to do a table if you wanted to that maybe is a little less tedious, less numbers for sure, 14 instead of 30. So we'll say amount again, but this is for caffeine. And you would continue it, but we would have 40, our rate 14. All right, go ahead and pause it here and try to evaluate your second, third, and 14th. Okay, so first dose was 40 milligrams, and something I really struggle with is making sure to label my stuff, so definitely make sure you're doing that. On the second dose, she had 42.4. The third was 42.544. And because you're doing it individually and you have this equation, it is okay to round. I tend to stick between 2 to 3 decimal points. I did write out all of them for 14 just so you can see that I'm rounding to the 0.55. So not too much more in between here. 40 milligrams of caffeine really isn't a whole lot. Tea is anywhere from no caffeination to 60-ish, depending on the tea. I know some that are 80. But like a Celsius or Alani are 200 milligrams of caffeine in a can. Pop is around 40. I'm sorry if you're a soda person. Pop, soda, same thing. 40 milligrams a can, or 60, 70 if it's a bottle, depending on the size. It should always tell you, but a cup of coffee is around 100 milligrams a cup. And espresso is like 63 milligrams. I am skilled in the amount of caffeine. I wasn't kidding when I told you I love it. So that is some of the ways those equations can be used. You had antibiotics where it's going to accumulate. You have caffeine where it's still decreasing, but when you continue to drink it, just like the antibiotics, it is going to remain in your system. Another example you're going to see later on is interest in a bank. Remember, interest is really good in banking because you are like passive income. You are getting that extra money without doing anything. It is bad when you have student loans or any type of loan really, because that means you're owing more money. So it's good for the person who holds the loan because they're going to get extra money from you. Not good if you have to pay that loan off. So you're going to see examples of that in the next lesson.